Good morning. I've come with another video finding the derivative of a function using the limit definition. So what you're going to do is finding the derivative of f of x is equal to 2x squared plus 3x minus 4 using this limit definition. That means we are not going to use any calculator. Okay, so no calculator. So we have to just simplify, get an expression for f prime of x in terms of x. So to do that, we take limit h approaching 0 of f of x plus h minus f of x divided by h. So limit x approaching 0, that is h approaching 0, 2 times x plus h, the second power, plus 3 times x plus h minus 4. This is for f of x plus h minus f of x, which is minus of 2x squared plus 3x minus 4, the whole thing divided by h. Okay, let's simplify this. See, at this point, if you substitute h as equal to 0 directly, then what you will get is a 0 by 0 form. So look at this. So in this case, say if I substitute h as 0 here, h is 0 here, and then simplify, it will become 2h squared plus 3x minus 4 minus of the same thing. So we have to simplify further. Limit h approaching 0, expand 2 times x squared plus 2xh plus h squared plus 3x plus 3h minus 4. Then let's simplify, remove the parentheses, so minus 2x squared minus 3x plus 4 divided by h. So we are going to simplify further by simplifying the numerator and cancelling common factors. So that will be equal to limit h approaching 0, 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 4 minus 2x squared minus 3x plus 4 divided by h. So even though there are many terms in the numerator, so look at the some terms will cancel. So I will cancel this. 2x squared will cancel with this 2x squared. Then plus 3x will cancel with minus 3x. And then minus 4 will cancel with plus 4. So you have these terms 4xh, 2h squared, and 3h over here. So we will write this h approaching 0 of 4xh plus 2h squared plus 3h divided by h. So here also we cannot directly substitute h as 0. If you substitute h as 0, each of the terms in the numerator will be 0. Therefore, what we have to do is, again, take common factor h. So that will be 4x plus 2h plus 3 divided by h. Now cancel these common factor. Substitute h as 0 here. So the one term will become 0. That is the middle term. So 4x plus 2 times 0 plus 3, which is equal to 4x plus 3. So that means f prime of x is equal to this. So this is an expression in terms of x. Likewise, there is another problem that we have written over here, which is okay, let me see if I can get that question. I have written another question over here. Let's see where the question is. Okay, let's stop this one for a while. Pause it. Okay, another problem over here is f of x is equal to square root of x minus 2. We'll do that as the second problem. F of x is equal to square root of so f prime of x is going to be limit h approaching 0 of f of x plus h minus f of x divided by h. Doing as per the limit definition, this will be square root of x plus h minus 2 minus of square root of x minus 2 divided by h. So if you directly substitute h as 0, numerator will become 0, denominator will become 0. That's going to get us nowhere. So we have to simplify in a different way. Since you see irrational expressions in the numerator, let's rationalize by multiplying and dividing by the conjugate of this numerator expression. So conjugate means you have the same terms, but the sign in the middle of the terms, that is, you have to multiply and divide by square root of x plus h minus 2 plus square root of x minus 2. What is the reason for doing this? Let's see here. We can multiply the numerators and simplify. So using this multiplication, multiply this x plus h with this one. So that will give you just x plus h minus 2. Then multiply the first term with square root of x minus 2. So that will be square root x plus h minus 2 times square root of x minus 2. And then multiply these two terms again, minus square root of x plus h minus 2 times square root of x minus 2. Then multiply the last term with the last term. That will be minus of x minus 2 divided by, denominator has not only h, also this expression, irrational expression. Don't expand this unless it is necessary. Okay, so look at this. These two are canceling each other. So you can see that this is canceling. The middle terms are canceling. This one cancels with this one. So what we have in the numerator is limit h approaching 0. You have x plus h minus 2. Then since you have a minus there, minus of, so you have a minus sign here. So minus of, so that will minus x plus 2 divided by h, then parentheses x plus square root of x plus h minus 2 minus, plus square root of x minus 2. So look at this numerator now. Some terms are cancelling in the numerator. So you can see that limit h approaching 0 of So I can cancel this x and minus x. Well, let me use a different color. So I can cancel this x and minus x, and then this minus 2 and plus 2. So I have h only divided by h times square root of x plus h minus 2 plus square root of x minus 2. Now I cannot directly substitute here. Numerator will become 0, denominator will become 0, so I have to cancel the common factor. Still, I finish canceling out all the common factors. I cannot substitute the limit. And so till I substitute the limit, I have to keep writing this limit h approaching 0. Okay, so if I cancel this, it will become 1 here. So it's going to be limit h approaching 0 of 1 over square root x plus h minus 2 plus square root x minus 2. Okay, x minus 2. So that will be x minus 2. Well, now let me substitute h as 0, so that at that time I won't write limit h approaching 0. So it will be square root of x plus 0 minus 2 under the square root plus square root of x minus 2. So it becomes 1 over square root x minus 2 plus square root x minus 2. Or it is 1 over 2 times square root of x minus 2. So this is the answer, f prime of x. Okay, we will meet in another video. Thank you. Bye-bye.